Hi and welcome back to the Core Learning channel. Today I'm going to be going through the June 2022 Maths GCSE Higher Tier Paper 2, which is the Calculator Allowed paper. So I'm going to be going through each question and showing how I would go about getting the answer. So if you haven't already, please hit that like button and subscribe to our channel. This really helps us grow and reach more people, so your support really does help. And with that, let's jump into our questions.
So for question 1, we want to equate the percentage 1.25% to a fraction. So what I like to do here, if we know it's a percentage, then this means that this value is out of 100. And we want to write this as a fraction. So we want to write this as 1 over something, which I'm going to call x. So all we need to do now is find what our value of x is by rearranging this formula. So we have 1.25x equals 1 times 100. So I've moved the x up to the top on the left-hand side, and I've moved the 100 across to the right-hand side. So 1 times 100 is just 100, and then we can bring the 1.25 across. So we have x equals 100 divided by 1.25. And if we use our calculators, this is going to give us 80. So we can see here that our correct answer is going to be 1 over 80. So for our question 2, we want to write the probability of A and not B. So what's the notation for this? Well, the probability of A and something is this N looking symbol. And then if we've got not B, we write a dash next to the B. So this means the probability of A and not B. So we can see that this is the last option on this list. So for question 3, it says which of these numbers is a triangular number? So a triangular number, if we imagine just going down, so we're going to start off with some dots, and we just add a dot each time, and it kind of makes a triangle. So we start off with 1, then 2, then 3, then 4, then 5, and we keep going, and we just add 1 each time. And the triangular numbers are the amount of dots, essentially, that make a triangle shape. So we start off with 1, and then we have 3, and then we can extend this to the next row, and you can see we've got 1, 2, 3, 4, 5, 6. And then we add in the next row, and we have 10. We add in the next row, and we have 15. So we can see here that 15 is an option. So 15 is going to be our answer here. So now we have question 4. So we want to know what the inequality represented here is. So let's do a reminder. An open circle means the value is not included, and a shaded circle means it is included. So here, this means 1 is included, and -5 is not included. So the values, or the inequalities we're going to circle here, are going to be minus, oh, that's incorrect, it's going to be -5, and then it's going to be less, sorry, it's going to be more than -5, so it's not equal to or greater than, it's just greater than, and it's going to be equal to or less than 1. So moving on to question 5, and we want to solve 5 times 2x minus 1 equals 6x plus 9. So the first thing we're going to do here is we want to expand out this bracket. So when we do this, we have 5 times 2x, which gives us 10x, and we have 5 times -1, which gives us -5, equals 6x plus 9. Now what we want to do is we want to bring all our x's to one side and all our number terms to the other. So I'm going to bring this 6x across to the left-hand side. So this becomes 10x, and it's a plus 6x, so it comes across as a minus 6x. And this equals 9, and this -5 is going to come across as a plus 5. So 10x minus 6x is 4x, which equals 9 plus 5. 9 plus 5 is 14. So x equals 14 divided by 4. And you can work this value out on your calculator, but I think just looking at this, because I don't have my calculator on me right now, this looks like it's going to be 3.5. So moving on to question 6, we want to show that 2,125 can be written as a cube number multiplied by a prime number between 10 and 20. So I'm thinking here, what we want to do is draw out a factor tree. So I'm going to start with a value that I know goes into 2,125, and that is 25. And I now need to work out what multiplies by 25 to give 2,125. So if I use my calculator, I can do 2,125 divided by 25, and I get 85. And I'm now going to break these down into prime numbers. So we have 25, which is 5 times 5, so that's done. We don't need to break that down any further. With 85, I can break this down into 5 and 17. So now all of our roots are primes, which means we can't break them down any further. So we can see here that we have 2,125 is equal to 5 times 5 times 5, which is 5 cubed, times 17. So this can be written as 125 times 17, with 125 being a cube number and 17 being a number or a prime number between 10 and 20. So now we have question 7. So this question says that Sam types a constant number of words per minute, and it says in 8 minutes he can type 416 words. And we want to know how long it takes him to type 1,544 words, 34 words, pardon me. So the way we want to do this is I want to know how long it takes him to type just one word. So the way we're going to do this is we can divide the time by the number of words to produce his rate of minutes per word. What I'm going to do here first of all is I'm going to convert this 8 minutes into seconds. So 8 mins, we know that there's 60 seconds in a minute, and there are 8 minutes. So we times 60 by 8, and this gives us 480 seconds. And what we're going to do now is we're going to divide this 480 by the number of words he can do in that time. And what this tells us is that, and I'll leave it as a fraction, is that this fraction, 15/13, is the number of seconds per word which he can type. So he does 15/13 seconds per word. So I'm just going to move this up slightly. So what we now want to know, now that we've got the number of seconds per word, we now want to know for how long it's going to take for him to type 1,534 words. So if it takes this long here to do just one word, then we can just multiply this by the number of words we're looking for, which is 1,534. And what this is going to tell us is the amount of time that it's going to take. So when we put this into our calculator, we get 1,770 seconds. So 1,770 seconds to type 1,534 words. Now, the answer wants this in minutes and seconds. So what we're going to do here is we know that there are 60 seconds in a minute. So we can divide this value by 60. And what this is going to tell us is the number of minutes it takes. So we put this into our calculator and we get 29.5 minutes. And 29.5 minutes is equivalent to 29 minutes, and half of a minute is 30 seconds. So here we have question 8, and we're told that we have an average attendance for a school play on Monday, Tuesday, Wednesday, and Thursday, and that the mean attendance is 90 people. And we want to work out what the attendance on Friday is. So the first thing we want to do here is recognize how we calculate the mean attendance. So I'm going to call this x bar, which is mean. So the mean of x is equal to, in this case, it's going to be x1 plus x2 plus x3 plus x4 plus x5 over the total number of occurrences, which is 5. Now, here, what do we know? We know that X bar, i.e. the mean, is 90 people for the week. X1, which is our value on Monday, is 72. X2, which is our value on Tuesday, is 83. X3, which is our Wednesday value, is 88. And X4, which is our Thursday value, is 97. So we now can plug these values into this top equation, and we're going to solve for X5. And in fact, what I'm going to do, I'm going to rearrange this first. So I'm going to rearrange this to make X5 the subject. So to do this, I can move the 5 on the bottom up as a multiplication to the left-hand side. So I have X bar multiplied by 5. And then I can move across the X1 plus X2 plus X3 plus X4 as a minus, because they're all pluses, and this leaves me with X5. And now I can just plug in my values. So I have X5 equals X bar, which is 90 times 5, minus 72 plus 83 plus 88 plus 97. So this gives me 450 minus, and then if we add all those together, we should get 340. And we work this out and we get 110. So now we're moving on to question 9. So question 9, and we're going to go on to question 9a. So Rosie makes phone calls to try to sell broadband. So we're told she makes 120 calls, and we want to know the relative frequency that a call was not answered. So we can see of all the calls she made, 33 were not answered. So the relative frequency just means, in this case, how many were not answered out of the total number of calls she made. And now we can simplify this a bit. So we can divide top and bottom by 3, which will give us 11 over 40. So moving on to part B. We're told that Rosie is going to make 500 calls during the course of the week. So we want to know how many sales she expects to make. The key to this is the table above. So we can see that for every 120 calls she makes, she produces or makes 6 sales. So 6 out of every 120 calls result in a sale. This can be simplified to 1 in every 20 calls. So what we want to know now is, if 1 in every 20 calls results in a sale, then for every 500 calls, how many sales will she make? So we want to equate this 1 in 20 to something in 500, which I'm going to call X. And now we're just going to rearrange this to solve for X. So X equals 500 times 1 over 20, which is just 500 over 20, which is 25. Moving on to question 10. So here we're told Harry has paid £80 for a printer and £25 for a hard drive, and Ellie paid 10% less than Harry for the printer and 20% more than him for the hard drive. And Ellie has said that she thinks she's paid more than Harry because 20% is greater than 10%. Is she correct? Well, let's work this out. So starting with the printer, we know that Harry paid £80. We're told that Ellie paid 10% less than this. So from £80, we're going to subtract, and it's going to be 80 times 10% of 80 is 80 times 0.1. So this is going to be equal to £80 minus £8, which gives us £72. And then for the hard drive, Harry paid £25, and she paid 20% more than Harry. So here, we're going to add on £25 and then 20% of 2.5. So we're going to times this by 0.2. So this is going to give us £25 plus, and 0.2 times 25 is 5. If I can draw a pound sign, plus £5, which equals £30. So all we have left to do now is work out the total amount spent by both Harry and Ellie. So for Harry, his total amount is £80. Oh my god, there's the worst attempt at a pound sign I've ever done, plus £25, which gives us a grand total of 105. And for Ellie, she paid £72 plus £30, which gives us £102. So what does this tell us? It tells us that Harry actually paid more than Ellie. So Ellie's statement that she thinks she paid more is in fact incorrect. So is she correct? Absolutely not. So for question 11, we're given two shapes which are combined together, which are a right angle triangle and a rectangle. And we're told that the rectangle has a height of 52 centimetres. I'll just put this right angle in here. We're told this side of the triangle has 16 centimetres length, the other side 30 centimetres, and we're told to work out the area of the shape. So the first thing I want to do is I want to find this length here, x. Now, if you remember Pythagoras' theorem, we call the side opposite the right angle h, and Pythagoras' theorem says that the other two sides, which I'm going to label a and b, the relationship is that h squared is equal to a squared plus b squared. So filling this in, we get that h squared is going to equal 30 squared plus 16 squared. Therefore, the square root, if we take the square root of both sides, we get that h equals the square root of 1156. So h equals 34 centimetres. So let me just write that in. So now we're ready to start working out some areas. So the first one, which is quite simple, is the area of a rectangle. So we've got our 52 centimetres and we've got our 34 centimetres. So the area of this rectangle is going to equal 52 centimetres times 34 centimetres. And I'm just going to check my calculator because I can't think what it is off the top of my head. So this is going to give us 1,768 centimetres squared. Remember that squared. And now we want the area of our triangle. So for a right angle triangle, and I'll just draw this upright as it's slightly easier to visualise. So if we were to have a right angle triangle with sides length 16 and width 30, and I were to put a line diagonally across, because it's a rectangle, because this is a right angle, when we complete the side on the other side of this line, it's going to be symmetrical. So this will have a length of 30, this will have a length of 16. And what this means is, and we'll just label this h, so this would be the hypotenuse, this dividing line. So what we can say about the area of a triangle, or particularly the area of a right angle triangle, is, I'm going to call these A and B, is that it's going to be the area of this whole rectangle, which is A times B, divided by 2. So the area of this triangle is going to be 16 times 30 over 2, and this gives us 240 centimetres squared. In fact, that's incorrect. That's just 16 times 30. It's going to give us 120 centimetres squared. This is why I use a calculator. This was incorrect. Yep, so I was right initially. It's 240 centimetres squared. So now our area total is going to be the area of our triangle plus the area of our rectangle. So this is going to be 1,768 268 centimeters squared plus 240 centimeters squared. And this gives us 2008 centimeters squared. So for question 12, we have 4y equals 5x, and we want to know which one of these statements is true. So what I'm going to do here is I'm going to rewrite this equation in two different ways. So first of all, I'm going to make y the subject. So doing this, we have y equals 5x over 4, or y equals 5 over 4x, which in decimal form is 1.25x. And then I'm going to make x the subject. So we move that 5 across, and we get that x equals 4y over 5, which is 0.8y. So another way we could write this in terms of percentage is that y equals 125% of x, and for here we'd have that x equals 80% of y. So looking at the statements we're given here, we can see that the correct answer is that y is 125% of x. So now we're moving on to question 13. So here we're given the volume of a cone and the volume of a hemisphere, and we want to know the total volume. So let's just draw out the shapes we have. So here we have our hemisphere with a radius r. And we also have a very poorly drawn cone, again with a radius here of r. And we're also told we have a height h to this. And we're given here that r in both cases is 24 centimeters and h is equal to 117 centimeters. We're also told the volume of the cone and the volume of the hemisphere. So we have for the cone that is equal to 1/3 pi r squared h. And we have r and h, so we're ready to fill this straight in. So this is equal to 1/3 pi, actually, I'll take that back, times 24 centimeters squared times 117 centimeters. And when we work this out, this gives us the total volume as 22,464 pi centimeters cubed. And now we'll do the same thing with the hemisphere. So the volume of the hemisphere is equal to 2/3 pi r cubed. And again, we only need r here, which we already know. So this is equal to 2/3 pi times 24 centimeters cubed. And when we work this out, we get this gives us a total volume of the hemisphere of 9,216 pi centimeters cubed. And now all we have to do is add these two volumes together. So our volume total is equal to 22,464 pi centimeters cubed plus 9,216 pi centimeters cubed. This gives us a total of 31,680 times pi centimeters cubed. And if we actually put in the value of pi and work this out as a decimal, we're going to get 99,525.7 centimeters cubed, and this is to 1 decimal place. So for part B, we're told that we have a real cone which has a radius of 2 centimeters. And what we want to know the ratio, or we want to know how many times greater the volume of the plastic cornet is compared to the actual cornet. So the cornet here is referring specifically to the hemisphere. So let's just make sure we fully read the question to make sure we're actually comparing the right things. So the volume of the hemisphere, if we remember, is given by 2/3 pi r cubed. So we want to know the ratio between the volume of this cornet, as they're calling it, or the volume of the hemisphere, between the plastic cone, which I'm denoting PC, and the volume of the hemisphere on the real cone. So we can actually quite simply do this. So the volume for the plastic cone is going to be given by 2/3 pi times the radius of the plastic cone cubed, divided by 2/3 pi times the radius of the real cone cubed. Now, we can actually just cancel out the 2/3 pi as it occurs on top and bottom. So we can get rid of this. And now it's just this ratio between the radius of the plastic cone cubed and the radius of the real cone cubed. So let's just put those values in. So the plastic cone had a radius of 24 centimeters. Sorry, apologies. It had a radius of 24. So that's going to be 24 cubed over the radius of the real cone, which is 2. So this is going to be 2 cubed. As this is a ratio, I'm not bothering with the units because the units in both cases were centimeters, so they're just going to cancel out. So we can leave it like this. Working this through, we get 13,824 over 8, which gives us 1,728. So what we're saying there is the volume of the plastic cone over the volume of the real cone is 1,728. Hence, the volume of the plastic cone is 1,728, the volume of the real cone. So for question 14, we are told that a sample is taken at a football game and they've been asked about the importance of a family area. And what we want to know is, given that the attendance at the game was 29,000, and this is for part A, sorry, given that the attendance was 29,250 people, how many people think that it is a very important area of the stadium? So we have a sample, and we're told that the sample should be representative of the crowd. So what we want to know is what portion of the respondents thought that the family area is very important, and then we apply that to the total number of people in the stadium. So the first thing we want to do is in our pie chart, which I'm just going to draw out quickly. So we have VI, which is very important. We have QI, which is quite important. And we have NI, which is not important. And we had 375 who said it's not important. We had 400 who said it's quite important. And we had 1,475 who said it was very important. So the first thing we want to do is work out the total number of people in this sample. So let's just add those number of respondents up together. So we have 1,475 plus 400 plus 375. And this gives us, if you'll give me a moment, 2,250 respondents. So what we want to know now is, out of all of those respondents, how many thought that the family area is very important? So this is going to be 1,475 out of 2,250. As a fraction, this is 59 out of 90. So what we want to do now is, we've said that out of every 90 people, 59 think that the family area is a very important section. So then the question we want to know is X out of the total attendance. So out of the total 29,250 people, what number think it's very important? So basically, how do we express 59 out of 90 as X out of 29,250? So what I'm going to do here is just rearrange to find X. So X is equal to 59 times 29,250 divided by 90. I apologise for the quality of my handwriting. And when we do this, we get that the answer is 19,175 people. Now, part B to this informs us that 50% of the sample was sitting in the family area, but only 10% of the actual crowd was sitting in the family area. Now, what this boils down to is that the sample is not representative of the crowd. And anyone who's sitting in the family area is going to be more likely to think that the family area is a very important idea. So what this means is we've overestimated, based on our sample, the number of people who are likely to actually think that the family area is a very important idea. So the box we're going to tick here is that it is lower than the answer to part A. So the number of people who think that the family area is important is lower than part A, or lower than 19,175. So for part C, we're given the following grid, which I'm just going to draw out. So it's a 3x3 grid. We have the following values. And we're told that the product of each row, column, and diagonal is 1. And we want to fill in the rest of these values. So I'm going to start with this column here. And what I'm going to say is I want the product to equal 1. So we've got a quarter times 4 times our unknown value, which I'm going to call y. And this equals 1. So a quarter times 4 is 1. So we have 1 times y, which is just y, equals 1. So in this case, our first value is 1. So now we're going to attack this diagonal. So here we have an 1/8 times 1 times y equals 1. So in this case, we now have 1/8 y equals 1, which means y equals 1 over 1/8, which equals 8. So now we can have a look at the row over here. So we now have an 8, or rather we have 8 times a quarter times y equals 1. So 8 times a quarter is 8 over 4, which is 2. So we have 2y equals 1, hence y equals a half. Now we can have a look at this diagonal. So we have a half times 1 times y equals 1. So we have a half y equals 1, which means y equals 1 over a half, which equals 2. So now we have two values left. So let's have a look at this column here. So we've got 8 times 2 times y equals 1. So we have 16y equals 1, and therefore y equals 1 over 16. So this was this value here. And we can finish up now. And I'll finish up with this row here. Just go down for a bit more space. So we have 1 over 16 times 1 times y equals 1. So we have 1 over 16y equals 1, which means y equals 1 over 1 over 16, which equals 16. Moving on to question 16. So we're told that Amol owns a sandwich shop, which is open Monday to Saturday, and he sold 3,000 sandwiches in June. He wants to work out the mean number of sandwiches he sold per day in June, and he said that I'm going to divide 3,000, the total number of sandwiches, by 30, the number of days in June, to get 100. We want one criticism of Amol's method. So what I would say here is he is only open Monday to Saturday, so his shop doesn't open on Sundays, which means if he truly wants to get the mean number of sandwiches per day, instead of dividing by 30, it would be better to divide by 26 or 25, depending on the number of Sundays there were in June. So shop doesn't open on Sundays. Number of days should be 25 or 30 or 26 instead of 30. So for part B, we're told that a mole received £6,660 for 3,000 sandwiches. We're also told that the ratio of meat to cheese to vegan is 9 to 4 to 7. Again, I can't apologise enough for how bad this handwriting is. And the price of a meat sandwich is equal to £2.39, and for a cheese it is £1.89. And what we want to know is the price of a vegan sandwich. So what we're going to do here is, given our ratio of 9 to 4 to 7, we want to work out how much of each sandwich was sold. That's going to be our first job. So what we're going to do is, if we take this ratio, the 9, the 4 and the 7, we can add this together. So we have 9 plus 4 plus 7 equals 20. And this basically represents 1 unit or 1 sandwich. And we can now divide the total number of sandwiches divided by this 20, and this gives us 150. So this is basically one lot of sandwiches. So 1 unit is 150 sandwiches. So applying the 9-4-7 ratio, for meat, we have this unit of 150 sandwiches times 9, which equals 1,350. So this represents 1,350 sandwiches sold. For the cheese, we have this unit of 150 times 4, which is equal to 600 sandwiches sold that were cheese. And for the vegan, we have 150 times 7, which is 1,050 vegan sandwiches sold of this 3,000. So now that we have this, we're told that the total price of those 3,000 sandwiches was £6,660. Well, we can now break down, we know that this price is a result of the total number of each type of sandwich sold multiplied by its price. So we can say that £6,660 is equal to, let's start off with the meat. So we have 1,350 sandwiches times the price of £2.39 plus 600 of the cheese times the price of the cheese, which was £1.89, plus 1,050 of the vegan sandwiches times, and we're going to call this price that we need to find out y. And what we want to do here is solve for y. So we have £6,660 equals, and if I work this out, for the meat, 1,350 times £2.39, that is 3,226.5. I'll just keep it in pounds. Plus 600 times £1.89, which is £1,134, plus 1,050y. So what I can do now is I can say 1,050y equals £6,660 minus £3,226.50 minus £1,134. This gives me a total of £2,299.50. So if we isolate y, we can move this 1,050 across. So y equals £2,299.50 divided by 1,050. which gives me a total price for the vegan sandwich of £2.19. Question 17. So here we have the plan of a solid, and we want to know what solid it could be. So if we remember, a plan means the shape we would see if we were to look directly from above at an object. So in this case, it's going to be a cylinder. So this is a cylinder from a side-on position, for instance. If we were to look at this from directly above, we're going to see a rectangle, aren't we? So for question 18, we're given the equation x squared plus 7x minus 11 equals 0, and we're told to solve for x. So the first way we could try and approach this is to try and factorize this. And the way we'd want to do this is we'd want to look to rewrite the 7x such that we have two values, a and b, that when they add together give us 7, and when they multiply together give us minus 11. Now, just by inspection and looking at this, I can't think of any two values, or at least not nice integer values, that are going to do this for us. So our second option here is going to be to use the quadratic formula. Now, the quadratic formula, for those who do not remember, is equal to minus b plus or minus root b squared minus 4 times a times c over 2a, where a, b, and c are the coefficients of our equation. So for our equation up here, and I'm just going to write this in red, so our a is the term before the x squared, our b is the term before the x, and c is going to be our number term. So going back, let me try and figure out, there we go. So our a term here is 1, because there's no term in front of the x squared, so it's just 1. Our b is equal to 7, and our c is equal to minus 11. So now we can just put these values in to this quadratic formula. So we start off with minus b. So if it's minus b, it's going to be minus 7 plus or minus the square root of b squared, which is 7 squared, minus 4 times 1 times minus 11 over 2a, which is 2 times 1. So that gives us minus 7 plus or minus the square root of 49 minus, and we have 4 times 1 times minus 11, which is minus 44. So this is 49 minus 44. So these become a plus, and this is over 2. So we just keep going and simplifying this. So we have minus 7 plus or minus the square root, and 49 plus 44 is going to give us 93 over 2. So our two solutions for x here are minus 7 plus root 93 over 2, and minus 7 minus root 93 over 2. And we want to express this in decimal form, so I will quickly check that now. So we have 1.32. So I'm going to do this to 2 decimal places. And then our other solution is minus 8.32. And be careful to just note this is to 2 decimal places. So moving on to question 19, we're told that we have a number of coordinates on a straight line, which are a, b, c, d, and e. We are given the coordinates of a and b, and we are told that a, b, c, and d are all equally spaced. We're also told that AD to DE is a ratio of 2 to 1. So one of the first things we can do here, and I'm going to just draw out this line, is we're just going to plot these coordinates, or at least the first 4. Now, we're told that they're all equally spaced, which means the distance, which I'm going to call h, is the same for each of them. And what we can also do is draw a right-angled triangle here. So we can draw a right-angled triangle to go from each coordinate to the next. I'll just draw it in here. And what we can say here is that because they're all on a straight line, if we were to take this angle theta in the right-angled triangle, we have the same h and the same theta. And what this means is that the change in the y between successive coordinates, so between A and B, for instance, is going to be the same between B and C and D. So the change in y, and I'm going to call this delta y. Now this just means change, and we use the Greek letter delta to represent it. So delta y is going to be the same for all. Likewise, the change in the x coordinate is also going to be the same for between each pair of coordinates. So if we take A and B, let's work out the difference in the values of the coordinates. So between A and B, we have A, which has coordinates 5, 26, and we go to B, which has coordinates 11, 22. And we have our x and our y, and our x and our y. So you can see here, our delta x, which is our change in our x value, is plus 6. So we add 6 to get from A to B in the x direction. And then for y, we go from 26 to 22, so we subtract 4. Now we can apply this transformation to each coordinate to get C and D as well. So if we want to work out the value of the coordinate C, we have, starting from the B coordinate, which is 11, 22. So we have 11, and then we want to apply a plus 6 change in the x direction. And then we have 22, and we want to subtract 4. So our C coordinate now becomes 17, 18. And then we could do the same with our D. So to go from C to D, we start with the x coordinate of C, which is 17, and we add 6. And then our y coordinate of C, which is 18, and we subtract 4. And this gives us a D coordinate of 23, 14. So the next piece of information that we're given is that to go from AD to DE is a ratio of 2 to 1. What this means, quite simply, is that if these are our AD and E coordinates, then the distance here, which I'm going to call H, is twice the distance from D to E, which will be half of H. So now we need to work out what the distance from D to E is based on our distance from A to D. So to go from A to D, we are going from A, which is 526, to D, which is 2314. So the vector that represents that change, well, to go from the x coordinates, so I'll just mark the coordinates here. So the change in the x here, to go from A to D, is a change of plus 18. And to go from 26 to 14 is a change in the y of minus 12. Now, what we can say here is, if this distance h between D and E is half of the distance between A and D, then the x and y components of that value of h, so let me just draw this just to be explicit. So we have A, we have our D, we have our E. What we have here, we have half h here, and we have h here. So we have our change in y, and we have our change in x. Likewise, going from D to E, we have a change in y and a change in x. So what we can say is, if our x and y components between A and D give us a length of h, then to give us a length of half h, we can apply a transformation of half to our x and y components going from D to E. So if we've said that our delta y from A to D is minus 12, then to go from D to E, it's going to be minus 6. And likewise, if our delta x going from A to D is 18, then delta x over 2 equals 9. So we now just apply this to D. So starting with the coordinate D, which I'll remind you is 2314. To get to E, we take this D coordinate and we're going to add 9 to our x coordinate, and we're going to subtract 6 from our y coordinate. So this gives us a final coordinate for E of 32, 8. So moving on to question 20, we are told that a company makes and sells washing powder, and for 1.68 kilograms, that will cost you £5.60. And we're told that they want to increase the amount of money that they make per kilogram. So to do this, they can either increase the price to £5.88 or reduce the mass of powder by X%. And we want to find what X is. So what I want to do here is, what this question is saying is, we can either increase the price to £5.88. So what is the price per kilogram if we increase to £5.88? Or how do we get the same price per kilogram by reducing the amount of powder? So what we're going to do is work out the price per kilogram when we increase the price to £5.88. So we increase the price, but we keep this the same. So when we do this, we get that per kilogram it is £3.50. So now, how do we reduce the mass such that the price per kilogram is £3.50? So to do that, we keep the price the same as it originally was, which is £5.60, but we divide by this new amount of powder, which we're going to call, let's call it Y. So Y amount of powder equals £3.50 per kilogram. So we can rearrange this, and we get that Y is equal to £5.60 over £3.50. Y is equal to 1.6 kilograms. So now that we've worked out this, we need to work out, given that the original weight, or mass rather, of powder was initially 1.68 kilograms. So initially we had 1.68 kilograms of powder, and now we have 1.6 kilograms of powder. What is that as a decrease percentage? So what I want to know is 1.68 minus 1.68x equals 1.6. So 1.68 minus what percentage of 1.68 equals 1.6. So we can actually factorize here. So we say 1.68 and then 1 minus x equals 1.6. And now we say 1 minus x, and we can divide through by 1.68 equals 1.6 divided by 1.68. And when we do this, this gives us 20 over 21. So we have 1 minus x equals 20 over 21. Therefore, we can rearrange this to find x. So we have x equals 1 minus 20 over 21. which, let's make the denominator the same here. So 1 can be written as 21 over 21 minus 20 over 21 equals 1 over 21. And 1 over 21 is 4.76. Question 21. So we want to know which of these is the equation of a circle. So quick whistle stop tour. We've got our circle on a graph. And let's just change this to red. And we want to know where some point is on that circle. So we've got our radius, we've got our y value, and we've got our x value. So let's call this r, this is the radius. We've got our y, and we've got our x. So the point on the circle is going to be given by x squared plus y squared, which is going to equal r squared. So we know this is Pythagoras' theorem. So we can see that of the equations we have here, the only one that fits is that x squared plus y squared equals 6, where in that case r would be the square root of 6. So for question 22, we're asked what the reciprocal of 8 to the power of 5 is. So if we have a number n, rather I shouldn't say equals, the reciprocal is just 1 over n. And as a general rule, if we have 1 over n to some power x, this is equal to n to the power of minus x. So if we have 1 over 8 to the power of 5, which is the reciprocal of 8 to the power of 5, then this is equal to 8 to the power of minus 5. So for question 23, we're given the quadratic 3x squared minus 16x minus 12 equals 0, and we want to factorise this. So what I'm going to do is write out what I want the final brackets in the final solution to look like. And I want it to look something like ax plus b, x plus c. So I'm going to expand this out now, which means I'm going to multiply each component by each other component in the brackets. So this gives me ax squared plus acx plus bx plus bc. Now I can simplify this as ax squared plus, and I have these two x terms in the middle, so I can simplify this as ac plus bx, and then we have our bc term on the end. And what I'm going to do is I'm going to compare the coefficients between the original quadratic and the expanded out version of the final brackets, which are ax squared plus ac. And as I said, I'm going to compare the coefficients. So what I mean by that, and I'll choose a different colour, if I can actually do it. So I've chosen red. So let's start with our x squared term. So we can see here, we have 3x squared and we have ax squared. So a is 3. Next, let's go with the yellow, and we're going to look at our x term. So our x term, we have ac plus b equals minus 16. Now we already know the value of a, we just worked it out, it's 3. So we can actually simplify this slightly. So we have 3c plus b equals minus 16. And let's choose nice green to finish off. And we have our number term. So we have our bc and we have our minus 12. So we have bc equals minus 12. So let's explicitly write out what we know. We have some conditions. Our conditions are that b times c must equal minus 12, and 3c plus b must equal minus 16. Now we can work out mathematically what b and c are, i.e. we can continue manipulating these formulas. However, it's a 2-mark question, we're not going to go that far, and there's a much quicker way to do this. So we can assume that b and c are both integers. So What are our integer pairs that multiply to give minus 12? Well, we have 1 times minus 12, I should say. We have minus 1 times 12. We have minus 3 times 4. We have minus 4 times 3. We have 6 times minus 2. And we have minus 6 times 2. So these are our possible combinations. And we just have to find the right one that gives us minus 12 and also minus 16 for 3c plus b. So looking through this, I think I know what the answer is. So I'm going to go ahead and see what happens when b is equal to 2 and c is equal to minus 6. So if I do this, b times c is our minus 12. And 3c plus b, well, 3 times c is minus 18 plus 2 equals minus 16. So given this is the case, these must be our correct values of b and c. So we now know we have a is equal to 3, b is equal to 2, c is equal to minus 6. So if we go all the way back to our original brackets, which I'll just highlight, so we have ax plus b times x plus c. So let me just write this out. So we have 3x squared minus 16x minus 12 equals ax plus b times, and it was x plus c. So now we can just substitute our values of a, b, and c in. So we get this is equal to 3x plus 2 times x minus 6. And if you really want to double check, which is always a good idea, you can re-expand these brackets out to check this does in fact give the solution we want. So let's just go ahead and do that. So we have 3x squared plus 2x minus 18x minus 12. Simplified is 3x squared plus 2x minus 18x is minus 16x minus 12. So for question 24, we are told that a straight line is perpendicular to a straight line through the coordinates 2, 8 and 6, 15. And this new line passes through the coordinates 0, 9 and x, 17. What is the value of x? So the first thing that we need to know here is that, and this is not a straight line, it's meant to be, but it's not very bad. It's very badly drawn. So if we have a straight line, and I'm going to call this a straight line with gradient m1, and then we take a second line, which we're going to say is perpendicular. So perpendicular means that there is a right angle between these two lines. And I'm going to say this has a gradient of m2. Then there is a relationship between the two gradients of these lines. So m2 is going to be equal to minus 1 over m1. So that is the relationship between the gradients of the two lines. Now, what we want to do is we want to work out the gradient of this perpendicular line, which is this m2 line. So to do this, we first want to work out the gradient of the original straight line, which, if you remember, had coordinates 2, 8 and 6, 15. And what I'm going to do is I'm going to label these coordinates with x1, y1, x2, y2. And our equation for the gradient of a straight line is the change in y, so y2 minus y1, over the change in x, so x2 minus x1. So let's just pop those values in, and we get 15 minus 8 divided by 6 minus 2, which gives us 7 over 4. So now that we have that, we can work out our m2. Now that we have our m1, we can work out our m2. So our m2 is going to be equal to minus 1 divided by 7 over 4. And this gives us minus 4 over 7. Now we know that the equation of a straight line is given by y equals mx plus c. So we can already say for this perpendicular line that it has a straight line equation of y equals minus 4 over 7x plus c. So now we just follow this through logically. So the next step is we want to know what the value of c is. The way we do this is we know that this perpendicular line passes through the coordinate 0, 9. So what we can do is, this is our x, this is our y. So what we can do is plug these values of x and y in to isolate c. So this gives us that 9 equals minus 4 over 7 times 0 plus c. Well, anything times 0 is 0, so we can just cross that out. So we can see that c is equal to 9. So we now know that our straight line equation is that y equals minus 4 over 7x plus 9. And now we want to work out this other coordinate. Now this other coordinate, we're told, has an x value which is unknown and a y value of 17. So again, we just plug these values in. So we have 17 equals minus 4 over 7x plus 9. So now we just rearrange to find the value of x. So we have 17 minus 9 equals minus 4 over 7x. So we have 8 equals minus 4 over 7x. Hence, x equals 8 times 7 over minus 4. So 8 times 7 is 56. We can take this negative outside. So it's going to equal minus 56 over 4, which is minus 14. So moving on to question 25, we have that this function f of x equals 2x plus 5. And we want to show that 3 times f of x minus 12 times the inverse function of x is an integer. So how do we work out the inverse function of x? So what we're basically asking is, this function, f of x, it takes an input and does some mechanics. So we'll call this transformation. And it produces an output. The inverse function wants to go the other way. It wants to start with the output and it wants to finish, I'm just going to call this transformation, and it wants to finish with the input. So it's asking the question, how do we go from the output, which is 2x plus 5, and how do we get to the input, which is x? So the way we do this is, let's call this x something else. Let's call this y. So we're going to say 2y plus 5 equals x. And what we want to do is we want to find a value of y here that returns x. So we just rearrange this formula. So we have y equals, we have 2y equals x minus 5. And then we have y equals x minus 5 over 2. And this value here is our inverse function. So this is our f minus 1 of x equals x minus 5 over 2. So now let's put these values into this expression that we're given, which is, so it's 3f of x minus 12f minus 1 of x. So this equals 3, and this is multiplied by 2x plus 5. And we're going to minus 12 times, make that a bit bigger, x minus 5 over 2. So let's expand this out. So our first bracket, we get 6x plus 15. And for our second bracket, well, we can simplify this a little. So we can cross out this 2 and this minus 12 and replace that with a minus 6. So we have minus 6 times x, so we have minus 6x. And then we have minus 6 times minus 5, which is plus 30. So we can see here we've got a 6x and a minus 6x. So we can cancel these out. and we're left with 15 plus 30, which is 45. So we've showed that when we plug in the values of f of x and f minus 1 of x, we do indeed return an integer. Question 26, we're told that pressure is equal to force per unit of area. We are told that two objects, J and K, are applying pressure to different areas of ground, and the force being applied by J is 18.9 newtons. The area it is being applied to is 0.45 meters squared. We're also told that the pressure being applied by J compared to the pressure being applied by K is a ratio of 7 to 8, and the area that the force is being applied to for J compared to the area the force is being applied to for K is in the ratio 9 to 5. And what we want to know is this force F of K. So the first thing we can do here is we can work out the pressure being applied to the area of ground from the force J and the area J. So this is going to be Fj over Aj, and this equals 18.9 newtons over 0.45 meters squared. And this gives us a pressure of J of 42 newtons per meter squared. So now we can use our ratios. So we're told that the pressure of J compared to the pressure of K is 7 parts to 8 parts. So if 7 parts represent 42, we want to know what 1 part represents. So 1 part will represent 42 over 7, which is 6. So 1 unit of pressure in this ratio is 6 newtons per meter squared. And if that's 1 unit, so I'm just going to write 1 unit of pressure. So if that's 1 unit of pressure, then for the pressure applied by K, the 8 units equals 6 newtons per meter squared times 8, which equals 48 newtons per meter squared. And this is our pressure from K. So now we have the pressure applied by K, and we can also work out our area for K. So we know that our area for J is 0.45 meters squared, and we can work out that this represents 9 units. Therefore, 1 unit of area equals 0.45 over 9, which is going to equal 0.5. In fact, that's incorrect. It's going to be 0.05. And I'll just write in the units, 0.05 meters squared. Therefore, 5 units of area is going to equal 5 times 0.05 meters squared, which equals 0.25 meters squared. So now we have everything, and this, just to be clear, this is our A of K. So we now have our A of K equals 0.25 meters squared, and we have our P of K, which, let me just double check, was 48. And the relationship is that P of K equals F of K over A of K. Therefore, F of K equals the pressure of K times the area that K is applying the force to. And therefore, F of K equals 48 newtons per meter squared times 0.25 meters squared. So we can cancel out the units of area here, and when we do this, the force being applied is 12 newtons. For question 27, we are told that a floor must have an area of at least 6.51 meters squared to be rented, and we're told that we have a bedroom which has a rectangular floor with dimensions 2.4 meters by 2.9 meters, and both of these are correct to two significant figures. So what this means is, and the way we're going to approach this, is we want to take the lowest value that these could be. So if we had the 2.4 meters, this could be 2.35 meters rounded up. Likewise, the 2.9 could be 2.85 meters rounded up. So this is the lowest interpretation of these two numbers based on the fact that they're correct to two significant figures. Now, if we multiply these two values together, we get 6.6975 and 6.6975 is pretty clearly greater than 6.51 meters squared. Therefore, the bedroom can be rented. For question 28, we're given the following shape. So, try my best to draw this. So we're given the following shape, and we're told that this is A, B, B, C, and D are the sides of a regular 12-sided polygon, which just means that all the lengths are the same. So, and we have a square here, this CDMN, and we want to prove that N lies on a straight line with A and B. What we first want to do is work out the exterior and interior angles of our shape. So for a regular polygon, and I'm actually just going to mark these angles. So what I'm going to do is I'm going to call the interior angles beta, and I'm going to call these exterior angles alpha. So, and if we were to continue that, this is how we work out the exterior angles. So what we can say and what we know is that for exterior angles for a regular polygon, the sum of these angles, which we've called alpha, is equal to 360 degrees. So if we were to do what we've done here, so we've drawn out two of these alpha angles, we could keep going. We could add this here as well, and we keep going around the shape. Now, we know that it's 12-sided, so we should have 12 of these exterior alpha angles. So what that means is, if the sum of all alpha is 360 degrees, then, and all these angles are going to be the same as well, so we can say that alpha is equal to 360 degrees over 12, which equals 30 degrees. So each of these alphas is 30 degrees. For the exterior angles, the sum of all these angles is going to be equal to n minus 2, where n is the number of sides of the polygon, times 180 degrees. So in this case, n is 12, so we have 12 minus 2, which is 10, times 180 degrees, which is 1,800 degrees. And what we do now is we can say if this angle here is beta, i.e. it's 1,800 degrees over, which I forgot to do here, so beta is equal to 1,800 degrees over 12, which is 150 degrees. So going back up, we can say that this angle here is 150 degrees. This CDMN is a square, so the angles in here are all right angles. So that's 90 degrees. So what we can do is, I'm going to call this angle here X. And what we can do is we can say that this angle X is equal to 360 degrees minus 150 degrees minus 90 degrees, which is 120 degrees. And then we need to work out the two angles here and here. And what we can say is that we know that the angle alpha, which I'm writing here, is equal to alpha because it's an exterior angle. So the angle CBN, I'll call this, so between these 3 points. So I'm going to call that, so CBN equals alpha, which equals 30 degrees. So now, if I know the angle CBN, I now want to know the angle CNB. So this angle is going to be equal to, well, the total angles in a triangle is 180. So 180 degrees minus 120 degrees, i.e. x, minus 30 degrees. So this leaves me with 30 degrees. So what we have is a triangle as follows, where we have this corner B, here we have C, and here we have N. This angle here is alpha, this angle here is also alpha, and then we have this angle X. Now we know that because this is the side of a regular polygon, and we know that this length, which forms part of the square, is the same. So, and I'll label that D. So we know that this length BC is equal to this length CD. Therefore, CD, because it's part of a square, is equal to the length CN. And what this means is BC is equal in length to CN. So what we're saying is we have a triangle where the length, and I'll just mark it in red, so this length and this length are going to be the same, and we also have two angles which are the same. So what this means is that our point N is going to be at the same level as our point B. For question 29, we're given the quadratic that y equals x squared minus 18x plus 70. And we want to complete the square to find the turning points. So let's do a quick recap. If we have a graph, and let's say we plot y equals x squared, which is going to look something like this. So this is y equals x squared. We can apply a number of different transformations here. So what happens if we want the graph of, let's say, y equals x plus a squared? So this is going to be a translation along the x-axis, so in this direction. Well, along this axis, I should say, not necessarily in that direction. So in this case, we would actually get a graph. Now, obviously, we haven't specified what a is here, but the point is that this coordinate here would be minus a. Now, we could then plot the graph of y equals x plus a squared plus b. And now this is a translation in the y-axis. So here we would move, so I'll replot this. So we have the same coordinate here of the turning point of minus a, but on the y-axis we have a coordinate of b. So we can use this to write something that looks analogous to this from our original quadratic equation, and using this we then know that our turning point, which is here, is going to be is going to have coordinates of b and minus a. So we can complete the square. So I'm just going to write out y equals x squared minus 18x plus 70. So the way we complete the square, if we remember, is we say that y is equal to, and we take x, and then we take half of this term here. So this is going to be minus 9. And we square it. And then we want to find this term c here. So we've said that y equals x squared minus 18x plus 70. And therefore this equals, and what we do now, if we expand out this bracket that we've just created, so if we work this out, we're going to get x squared minus 9x minus 9x plus 81. So, and also this plus c term. So now we need a value of plus c that takes us from plus 81 on the end to plus 70. So basically what we're saying is, you know, these parts are the same. This is the same. So I didn't simplify here, but we have minus 9x and minus 9x, which is minus 18x, so we can cancel out on both sides. So we're left with 70 equals 81 plus c. Therefore, c equals 70 minus 81, which is minus 11. So what this means is we can say that y is equal to x minus 9 squared minus 11. So now, let's compare this to our generic formula, which we had y equals x plus a squared plus b. And we said the turning points are going to be negative a and plus b. So in this case, our turning points here are going to be, well, negative a, so negative 9 is 9, and b is minus 11. So these are going to be our turning points.
So thanks for watching, guys. Hopefully you found that useful. If you have any questions or even just feedback for how this could be more helpful, leave a comment and I'll get back to you as soon as possible. If you haven't already, hit that like button and subscribe to our channel. As I said at the start, this really will help us grow, so your support is really appreciated. With that said, all the best, guys, and I'll see you at the next one.